This whole idea stems from the very first project that I encountered at Paragon. The very first project that I saw that the company had done, and this was the stadium in Johannesburg. And the whole idea behind the stadium was basically because stadiums before were done, but the scale and the scope was quite small. So we have always explored spaces in ways in which there's always something new that has been tried into a project, and this particular project basically explores that idea of working with engineers and working with structure, and this is what I call science, because if you can dream all you want, you can sketch all you want, you can develop all you want, but if you don't know how stuff works, you basically wasting your time. That's basically what I call science first. You can be the best designer, you can be the best concept developer, you can basically be Da Vinci, but Da Vinci without the science is basically useless. So I'll take you through just a quick series of projects. This is an analogy that I have for the whole concept, and I've divided this thing into a versus system. And my versus system that I explore is contradiction. Basically, architecture is a contradiction in that I'm basically speaking and saying that science, architecture is science first and art second, but then I come back and contradict myself again and say they both need to come in and work together. So that's basically what we're talking about, multi-part versus modest. I feel that architecture should ultimately be a conglomeration of basically different aspects that come together, the multi-part versus the modest. So you should be able to come from a simple concept of design and then use separate elements and separate ideologies to make that then come back and give you a project. Whether you're exploring it in a sense of sustainability, whether you're exploring it in a sense of political alignment, whether you're working with a small project to the largest project, it doesn't matter as long as it's a multi-part system that then again traverses back and becomes modest, and it's one of the ways in which you work. So I'll take you through the AFGRI building, which basically was a building where probably the very first buildings that Paragon explored the concept of concrete, malleable concrete, and subsequent projects have basically been developed to rival this, and ideas and concepts have been developed with the office, with engineers, with facade designers, with all these other people to basically bring us to this. And I don't want this to be architectural Tinder, where you've seen this idea where people go on daily and basically flip through fancy images. I don't want this presentation to be about that. So I call that architectural Tinder. You're basically doing this on daily, and you reducing the whole essence of architecture to that. I feel that there should be an understanding of how these buildings come together, the effort and the extensive processes that go to make a building get from a sketch to Revit to site, and that's basically what I'm here to talk about, which is what I call sci-fi. So it's not like a out of space experience. So the whole idea behind this building was to achieve a homogeneous concept to the concrete, so that you can get this. I think Paragon is quite big on this idea that separate entities of a building need to work together, and this was probably the very first building that they did that basically comes back as a courtyard. So we have different wings in the building that ultimately converge into central atriums, and then the outside basically just works as an envelope and wraps it up. And so the whole idea of formulating this into the formwork, into the concrete, was very important as an aspect of creating the whole building. And one of the main ways in which we are able to achieve such buildings is because we have adopted current standards of doing structure. And this is probably one of the biggest things that you have to be able to explore from the beginning, the structure of the building. It's what makes or breaks a project. From the onset, from the first time you designing a building, you have to know whether it will stand, whether it's leaning forward, whether it's leaning back, whatever form you come up with, the cardstock architecture, you have to be able to convert this into a real world project. And so if you look at this project, you can see the actual size of the columns are very minimal. It's probably a 300 millimeter column, which is this size. It's basically tiny columns that are supporting the whole project. And this is because we've gone in and explored our flat slab system that treats the whole structure as one system rather than developing it into ribs and blocks. So you see, you get into buildings where, if you look at the structure, and some of the buildings are done in Nairobi are like that. I'll give you an example of maybe Britain, where they explored the idea that you're not using individual beams and blocks, you are treating the whole floor as a structure, so that the moment you have that and you wrap that entire thing around, you've already created a structural component that's so rigid and that's so strong that you just need tiny elements to support it. And with that, you've basically freed up the whole building. So that's probably one of the projects that explores this. And you can see the structural system is very simple. It's a expansive system with central atriums and the glazing, and then it comes back together to sort of deal with the light with narrow shades on the sections where the offices actually exist, and opens up into the central atriums where no facilities for the tenants actually exist. And another interesting concept that we went through was, if you look at the actual finish of the concrete, you can see it's tiny, broken up ceramic pieces that basically were recycled into the building to make it feel like it's some sort of like a tectonic, like a sustainable way of using materials and then bringing it back and giving the building character. So you can see it clearly there, the patterns that are broken down to give the building a more sort of not necessarily cultural, but like a different feel to the project in a nutshell. So this is just basically public piazzas that we go through to create. The program of the building basically dictates that the bottom part of the structure is parking. So we usually lift up the entire building, create a fabric to the street, and then you access the building. And then so when you lift up the whole building and create a platform, you create piazzas where people can get out, people can explore, sort of like some of the spaces that we do experience here. The other thing is, apart from structure, you really need to know your stuff with facades. So if you look at some of the glazings on this building, they're quite large pieces in the curved section. So we work extensively with facade engineers and facade contractors to basically detail every single element of the building, so that if I show you a Revit model that we've done, or a Rhino model that's been done in the office, it's exactly the same thing as the final project. I did this presentation earlier and I was explaining this and people were like, no, but it's exactly the same thing that we design in the office. It's exactly the same thing you will find on site. There's no stray beam, there's no stray service, there's probably 95% clash happening on site, and it's all because of the aspect that we take. We treat architecture as an art, yes, but an art that needs to function. So we always tie it with science. At least personally, I treat it like a 95% science. By science, I don't mean always working with like structural facade. I mean developing the facade, the interaction between people, the social aspect of the building. How do people relate with it? This is ultimately what I call the sci-fi experience into a building. And the whole concept of raw versus polished, it's still that fight between how do you get something that relates to the people that you're designing it for, versus how do you then refine it so that there's no part of it that feels as if it's been added later. Everything is on one homogeneous, continuous context. And to illustrate this, I'll probably take you through the Alexander Forbes building, which is one of the buildings in the office that has a 5-star rating sustainable index attached to it. And the whole idea behind this building was to create a space for the staff of Alexander Forbes that basically plays into their aspirations. In as much as it sounds like a cliche, everyone here, I believe, aspires to a certain level of of excellence, a certain level of dignity. And the idea behind this building was to bring all these people into one building and use the program of the project to basically combine everything into one seamless movement through the building. So the whole building basically looks like that. It's two sections to the building. You have the main office spaces and the subsidiary larger spaces, and that the whole concept of the podium, lifting the building, creating piazzas, basically is best illustrated here. And at Paragon, ideally, there's always this debate of whether an architect should stick to a single ideology or whether they should explore separate entities into the building or the work that they do. Personally, I believe I should stick to one system, learn it best. I believe the only way to break rules is to learn them. So for the past few years, I've basically been learning the rules. How do we get stuff to work? And the building was envisioned as a podium with a piazza above the parking, articulated with separate entrances, with central atriums, and capped at the top with extensive cantilevers that basically gives the pavilion at the top the shading that they require. And these elements there made in Rhinezinc are this was the first, I think, if I'm not wrong, the first time that we were using Rhinezinc. It was new in South Africa. No one really wanted to explore and work with it. So Paragon basically went into a process, and they convinced the team at Rhinezinc to basically explore with Paragon and develop the facade, and it turned out right, I think. The science in this just comes in the way the building has been put together, how the fins have been angled because of the sun, the tiny, so this is your east, that's your west. You can see the glazing at the center is fully glazed to give you the experience that we want, but it's recessed so that the sun doesn't necessarily get in your face. The funniest thing is the sun in Johannesburg is 10 times as worse as the one in Kenya. It gets up to 45 degrees, like currently it's summer, so it's up to 45 degrees, and most of the buildings there, they heat up really quickly. And the culture especially in Santon, the culture there has quickly moved, if you look there, back there, has quickly moved from a somewhat sustainable, modest building to fully glazed structures that are every day competing with each other. And this was one of the buildings that basically explored how you can not sell out but still give people a modern identity and still give them modern spaces that are in a way cool. So the interiors of the building have basically been designed to carry the functions of the building across each section. You can see the science in this comes from how we've explored how the structure works. The flat south system at the top, you can see the columns, how they hold the bridges and the passageways, and this all ties back to the functionality of the building. Nothing is for aesthetics. Everything is developed in a way in which it will basically further down the line enhance the performance of the building. The whole reasoning behind this structural system was to detach some of the spaces from the main office spaces so that you can have corridors which can then work as breakout spaces. So if you feel like you want to leave the office, break out into a separate space, then you can walk into these podiums. And I think I have a picture that, so that's basically the construction process, how you involve engineers, contractors into one homogeneous process, I think. Earlier in the morning, I was having a site meeting for one of the projects we're doing here in Nairobi, and the interesting thing I found working through with this ideology that I have of science first is that you're always learning from someone, and someone is always learning from you.